Very good morning. This is Dr. Senthil Kumaran, Assistant Professor, Department of Electronics and Communication Engineering, Tyagarajar College of Engineering, Madurai. Now, today we will see a screencast video presentation for the topic maximum a posteriori probability. First, let me have a discussion with the difference between the maximum likelihood and maximum a posteriori probability. In the situation that if we assume that the source symbols are of equiprobable, then in that case we will find by using this maximum likelihood criterion. But in the case of this maximum a posteriori probability, we assume that the symbols are of not equiprobable. That is, we are utilizing the prior beliefs from the experiment, and with that we will be using this source probabilities as difference not like equiprobable. Then by analyzing this we will be taking the decisions, and this we call it as a maximum a posteriori probability. That is the base rule, models by learning from experience. That is, from the experience only we will be getting the clue, and from that clue only, that is from the prior beliefs, we will be declaring the decisions by using this map. In the natural world, our prediction is influenced by our prior beliefs. Mapped estimation takes our prior beliefs into account. By this only we will be using this map estimation, but in MLE we are not utilizing these prior beliefs. That is, whereas MLE does not. Map pulls the prediction towards the prior to an extent that depends on the strength of the prior. Map is closer to our natural style of prediction. It takes our bias into account. That is, from the clue we'll be having the bias that is towards this plus 1 or towards this minus 1. So with respect to this bias, by using this bias, you'll be finding this maximum a posteriori probability. And let me ask a reflection spot question. What you do is you think of what now we have seen about the ML and map, and the question is distinguish between maximum likelihood and maximum a posteriori probability. And now we will have a pause with that, just to think of that, and then we will answer for that. Yes. Also that you have think of the right decision of the difference between the ML and map. That is, let me tell me the answer for that. In maximum likelihood, the source probabilities we will be having using is of equiprobable, but in case of map, the source probabilities will be different and it won't be equiprobable. That is, we will see in the next slide that here we have the decision here. That is decision here, and for x2 we have this condition probability p of y given x2 and p of x2. This is a base rule, and the denominator part p of y, we assume that it is 1, that is maximum probability, it goes to 1, and only we will be having this one, and we will be using this prior beliefs, and we use that p of x1 and p of x2 is not to be equal, and these probabilities will be indifferent. And by using these different values, if you analyze it, then we call it as maximum a posteriori probability. Maximum a posteriori probability. Okay. And now the another situation is the map tends to look like an MLE asymptotically as n tends to infinite. So if you do many number of experiments, this map will tend towards this maximum likelihood estimation. Okay, and let me have one small example with this. In this there is we will be deriving this decision threshold y by using this map decision boundary. Okay, and now here we assume that the two symbol probabilities x1 and x2. X1 and x2 here, and we will be using this likelihood decisions. that is likelihood decision by using this Gaussian PDF. That is 1 by root 2 by sigma e to the power minus y minus x1 whole square by 2 sigma square into this individual source probability. And similarly here also we will be using this Gaussian PDF equating. Our motivation is to find the threshold, decision threshold region y. So what we do is we will be taking this log on both the sides and simplifying these expressions, and finally we will be getting the value of y. And in that expression we can see that this x1 plus x2 by 2 is there, and we have the another second term is sigma square by x1 minus x2 and ln of p of x2 by x1. So here in the second expression what we are going to do is we will be substituting this different probabilities, because in map we will be using this source probabilities and this won't be an EQ probable. So if you use this, definitely this decision boundary will be shifting towards with respect to this second term. Okay, so like this we have to find the decision boundary in case of maximum a posteriori probability. Let us see one example. That is, this example is an prior for learning by doing activity. With this we will be doing this example problem, and in learning by doing activity we will be solving this problem. Okay, and from this we will be posing two questions as a learning by doing activity. In this example we will see that consider a random variable x belongs to -3, -1, +1 and +3, and this is an 4 PIM system with prior probabilities px of plus or minus 3 is equal to 0.1, and this px probability with respect to this +1 and -1 is 0.4. So here we can see that these probabilities are not equiprobable. If these are equiprobable cases, then we have -3 probability of -3 is 0.25, -1 is 0.25, +1 is 0.25, and +3 is 0.25. So but here in this case it is not so. And given an observation of the random variable y is equal to x plus n, where n is a zero mean Gaussian random variable with variance sigma square independent of x. And find the decision regions for a map detector. So by using this example we have to find the decision regions, and the question is, if we have sigma square is equal to 0.25 and if the receiving signal is at y is equal to 2.1, then to which symbol we have to decide at the receiver side. So that will be the question. Okay, and we have seen that this x cap at the receiver side x1 belongs to this x1 with noise. Similarly x2 we will be deciding at the receiver side we will be having x cap, and that is with respect to this noise x2 plus n. Similarly x3 plus n and x4 plus n for -3, -1, +1 and +3 symbols. In the first case what we will do is we will take these regions, that is with respect to this -3 and -1. Then we will substitute these values in the decision threshold region we have found as an expression previously. Substituting this -3 and -1 here, and we know that these probabilities are different. Substituting these two different probabilities from the equation, and now the decision region will be -2.1733. But in case of maximum likelihood, obviously the decision threshold will be -2, because at exactly the center -3 and -1 we will be having -2. But since if these source probabilities are different, the decision region y now will be shifting towards -2.1733, that is shifting towards this -3 region, -3 symbol. Similarly now we will see as in case 2 for these two symbols -1 and +1, and we know that from the question the probabilities of -1 and +1 are equal, that is 0.4 and 0.4. So if we substitute these values -1, -1 here and these probabilities, we know that this term will become 0, that is log of 1 will become 0 and this term will become 0, and exactly we will get this threshold at the 0 center between -1 and +1. And similarly in case 3 what we will do is we will go for these values of +1 and +3. Similarly substituting this +1 and +3 values and these individual probabilities of +1 and +3. Now here also we can see that this decision shifts towards 2.1733. Okay, so as in conclusion that we can note that the decision regions bit at y1 and y3 are shifting towards -2.1733 and 2.1733, whereas at the center we will be having exactly at 0. Okay, now from the question we will see that if our incoming signal is plus 2.1, we will be favoring in case of plus 1 or plus 3. That is, in the previous, if our incoming signal is 2.1, so obviously the plus 1 and plus 3, if the signal is 2.1, obviously we will favor in case of 3. But by using this prior probabilities, now the threshold region is at 2.1733. So the receiving signal is 2.1. So this 2.1 is left side of this 2.1733. So now in this case we have to decide in favor of plus 1. So that is why we will be seeing here, even though if the received signal is a 2.1 as given in the question, the decision will not be in favor of plus 3. In this problem, with the source probabilities px of plus or minus 3 is 0.1 and px of plus or minus 1 is 0.4, we obtain the decision regions minus 2.1733, 0 and plus 2.1733. The received signal plus 2.1 is now at the region y2 to y3, and this corresponds to the signal component plus 1. Hence the decision will be in favor of plus 1. So as in conclusion, we will see that since the source probabilities are not equiprobable, that is, these prior probabilities, we have to consider these prior probabilities and we have to take the decisions, and with respect to these decisions, we will be finding these maximum a posteriori probability, and we will be concluding that, for example, in this case what we have seen is, even though if the signal is 2.1, we have to favor in case of plus 1. I hope so we have understood maximum a posteriori probability, and thank you. We will meet in next session. Thank you.